and upload it to you on Teams in general, and you'll be able to watch the video again. Okay, so here we start. I'm going to share my screen, and again to have the example of the hand pump project here. Okay, so this will be the second example for the hand pump project report. As you can see here that they have the cover page. They had the student numbers and name very clear, because in case that you need to submit the things individually, I think that the marker again to need these details and distribute the degree, like the marks later to your report, is going to be much easier for him, for example, take a snapshot and find out who are the students who work with this report. Once again, the table of content is very important because it's going to lead the reader what do we have in which section and which page. And also we are going to have an introduction and introduction analysis and diagrams. I don't know what they call it this way, but anyway, it's introduction. So you can see in this introduction, they have very nice flowchart for all the processes of manufacturing, ending up with manufacturing of the gear pump. So we had the formulation of the pump design, the creation of the drawings and CAD models, the identification of the necessity for 3D printing components, if you are going to have some. For your case, you did the machining. Let's decision at this point, so you can change that. Printing necessary components if you have, cutting the PVC pipe, cutting and threading the rods, drilling the hole in the cap, assembly of the water pump components, testing of the water pump components, and the final assessment. For 3D printed parts, components that need to 3D print are the piston components, the valve components, and the adapter. I think that he had a bigger size for the main body to be 18 millimeter, so he needed to have an adapter from the 40 to the 80. Now, if you're not doing that, you'll write down multiple streams. For example, this will be your design. This is the CAD model, or you start first with the principal design, like the hand SketchUp, and then you try to separate the thing, make the CAD model, and start the operation in parallel. So the first operation, for example, is going to be preparation of the PVC pipe. So this will be the cutting of the PVC pipes in the first step, and you can mention actually what are the parts you cut, which was the main body, the other part at the top, and also the extension for the water flow. The other stream, the one downward, is going to be like, for example, the design of the piston, and then you either 3D printed the things or you machine the part. So you'll mention this operation, and you do the pre-testing for the pressure for this one. When it's finalized, you're going to go for the last stage, which is going to be the assembly. All the streams are going to be linked to one box, which is going to be the assembly, then the testing of the whole pump. The third stream is going to be the design and the building of the foot valve, and what else? Yeah, the cutting and the threading of the main shaft. Okay, and the same thing for the handle. So all the streams which working together, they're going to be assembled at the end, do the testing, get the final result. Then you can add another block there to say that the assembly and recirculation of the component. Now your pump is there, you can take it out, take off all the parts. You can add this section of the assembly time and the assembly time, because this will be a time added to the manufacturing process. When you are going to do mass production for this pump, you will make all the parts individually in the 4 streams or the 5 streams again parallel. Then you'll send all the components to the assembly section, where you're going to have the workers going to take the parts, assemble the pump, and it's going to be ready for work. They will send it and sell it, for example, or send it for the aid work for the people who don't have water. After that, after the lifetime finishing of the pump, you need to recycle it. So what you are going to play here is the same role model. You are going to take your pump, deassemble it, and you will say that the time required to deassemble the pump is going to be, for example, 35 seconds. Now, much easier as the assembly process, that's mean you are going to have much efficient recycling process. When I say recycling, because now the recycling is one of the most important topic we have in our daily life. You can classify the parts, you can name them, and you will say, for example, that the main rod is made of aluminum. So this, and the handle is made of aluminum. So 1 and 2 are going to be aluminum recycling. So when you're going to put it there in the box, just put it individually. So the people upstairs, when they're going to have the dump material, it's going to be much easier for them to classify the material according to the type. So PVC pipe will go to the PVC pipe plastic recycling. The aluminum will go to the aluminum recycling. The nylon, maybe it's going to be dumped because it's usually very hard to be recycled. For the bolts and the nuts, you can simply reuse them. So just put it back in the box, the metal one here and the plastic one there, if they're in good shape. Still have good thread, good shape. So just put it back in the box so the people next semester can use them. For the T-junction, we didn't do any work on it. We just use it. So just take it and put it back in the box. So the university doesn't have to buy a new T-junction next year, right? So just use the same one for the next semester. So this is what you're going to add in this flowchart. You can see that reading the flowchart is going to be much easier for the marker than reading 100 pages. Actually, what we put here is replacing the same amount of 20 pages writing. So description of the, well, you can see that he have some description for the work, like this process will general outline for both the design and the construction of the water pump, and is understood that this process will not be a final, as the design manufacturing process may need a change to rectify the issue that arise and or to improve the overall operation of the water pump. You should decide that in the first week, what you are going to do and who's going to do it. This your part as the group leader. Description of the target of the product and its application, some background information, you can get that from the sheet we had. Why we need this pump? What's the main reason of making this pump? We said that many of the people overseas, they had the ability to, for example, dig a very narrow well, and they don't have the money to purchase the pump. And most of the pumps actually is very quite expensive technology. So you can simply have this hand pump. It can be a longer length, and they can use it by hand, just put it inside and pump the water. This small amount of the water they have by hand is going to be enough for the daily use, and it can save life because it's going to be fresh water, it's clean water, better than the water they can collect from the rain. So you can see that what the problem is and why we are going to solve it. And well, that's actually a good introduction. Here the initial design of the water pump, how it's worked, and usually what we're going to have is the valve going to do the difference in the pressure in the chamber. So by pulling up the thing, the bottom valve is going to be open, let the water in due to negative pressure, and when we're going to push it down, we're going to pressurize the water in the chamber because the lower valve is going to be closed, and this will push up the water to the top. The function of the working condition of each component. So you will see what the function of the pipe and the main chamber, the piston, the rubber valves. I will leave that for a while so you can read and rephrase. The most important thing actually is going to be the structure, not the content, because you can write down your contents. Using all the adapter in their case because they need to expand the shape. The cap, equal T connector, and the M6 thread. The formulation of the pump design. So we start with the hand-drawn sketch. We meant to do that in the first week, if you remember. So you can sketch something similar to that. They put the design of the suggested valve and the piston, how they look like. Obviously, this one was 3D printed, and the the rubber valve can open like a butterfly. I think you use the one which is flipping, right? So yours is a flipper. The bottom valve is a flipper, right? Yeah. So you can also show that by hand drawing and how it's going to work. And you can show the photo for your top valve. I didn't see how it looked like. CAD model for each part they made. Definitely they have to do the CAD model because they 3D printed this part, which is the adapter, but I think it's going to be much easier to do for all the things. Which part is that? I cannot. This is the cap, and this is the top cover place. Well, that's one at the top. The main shaft, the T tube. This will be the valve bit base. It's going to be something similar to yours. It's going to have the flip thing. Okay. The valve bit, the one is going to be moving. The full assembly of the pump components. It doesn't have to put the washers in this diagram. This is the fully assembled part. Different cross section, how it's going to work. The full stroke and the bottom stroke. And the de-assembly of the part by doing the explosion view. And then he's talking about the materials used. So usually the main part of the material was the PVC. If you use the valve which machine, you'll mention that this one was a nylon. If you use a 3D printed one, it's going to be 3D printed material. For your case, I saw that the foot valve was the PVC, so you write down that it's going to be made of PVC. So you can see what the PVC, what the material we use, 3D printing, the steel. What is steel? Actually, the rod or the shaft is aluminum. There's no steel, so you have to remember that. The rod we use is aluminum. Now, advantage and disadvantages of the material in the pump for the PVC. What the advantage? What is disadvantage? What are the alternative? And definitely, if you would like to make a long-living thing, we can use the aluminum shaft. But this will be quite expensive for the third world countries. So it's going to last longer. Recyclable, but it's expensive. It's more expensive than PVC. And also what's happened that if you ever heard about an organization called Engineers Without Border, they don't prefer to get the most expensive material. They only get to take your engineering drawing and your design and send it to the people so they can make it by themselves. So they tell them how to do it. They can do most of the cut by hand for the PVC pipe, and they maybe only going to make the multiple valve and send it to them. So they can simply just assemble the part, and that's why we need to make it as simple as possible, because the people usually are going to have they're not going to be a handful of people. They're not experienced people. They would like to follow the catalog, put the part together, and make it fun. PVC. We're still writing down about that. They say clay. No, we don't use clay. Maybe if you say the ceramic is okay, but not the clay. For the steel, no. Well, first it's aluminium. The alternative can be the steel. It should be the other way around. 3D printing. It said freedom for the design as the advantage, rapid prototyping, print to demand on demand, lighter but stronger parts, reduce the waste, quick and effective cost, and so on. Limited size, cannot be produced at large volume. Certain area must be weaker due to the process of the layering. Another disadvantage we have for 3D printed material is that the accuracy of the size. Usually when you're going to 3D print, the part is going to be hot. When it's going to be cooled down, it's shrinking in size. And this will give you a very high possibility that you are going to be out of tolerance. It's either going to be smaller. That's okay. or is going to be a little bit larger. The problem is that we cannot machine it because it's thermoplastic material. Due to the friction, it will damage very fast, and I think that we did that with, tried to do that with some of the grooves here. Alternatively, we can do the die casting if we're going to do it with massive production. Injection molding. We're going to make the mold have the multiple cavities of the food valve and the piston valve. So just inject it and we can have 10 to 100 parts at the same time if we would like to do massive production. Another operation is, we talked about the plastic actually this week in the lecture. One of the possibilities is we have the resin and we can, or the epoxy, we can mix it, put it in the mold, even manually, put it in the mold, leave it to solidify, we can take it out, it's going to be ready. Again, the process is going to be quite small, but if we're going to have a big mold with multiple valve positions and we're going to pour the resin in each one of them and leave it to solidify in 48 hours, well, when I say solidify and the cure at 48 hours, then we can take the part out. It's going to have very nice surface finishing because it's going to have the same shape of the mold. It doesn't have pressure, but its weight is going to fill the cavity and we're going to have the good tolerance. Again, it's going to have the best surface finishing at the wall because you know that the resin is going to be liquid material. It's going to be attached to, for example, this surface, which is the plastic mold. It's going to have very good surface finishing. So this can be another example, the casting, but it's not metal, it's casting with using the resin. The alternative here was the buying of the parts itself, or the opposite, subtract manufacturing, insert of the adding layers, yeah, well, mean the cutting material. Okay, so ideal for bigger, not ideal for. Actually, I think that I will suggest to do the casting next semester for some of the students. We'll try to make the mold, and we can do the thermoforming for the mold, and we start to pour the material and leave it solidified, and they can use it directly. This would be actually a good experience. For the manufacturing, the proposed manufacturing processes and operations and pre-flow chart. Again, the flow chart can tell a lot. You don't have to, actually each block can be a half page. Put the block, number them, and this is simply again to show you what will be the process you need to follow. So I'll leave this one for a while so you can take a look on it and try to figure out how to make something similar to it. The components number and description, the cab with the 6.5mm diameter hole center, manufacturing process, additional comments, alternative material, the PVC pipe, same thing. The equal T connector, 40mm, no manufacturing required, or you can say it's off the shelf item, because we just get it from the shelf and use it directly. Preferred by VCT connectors was used, low cost, don't say the word cheap. The cones can be 3D printed, yes, but actually it's not going to be strong in this one because this one was done by the injection molding. That's mean the component is going to be more tightened and thus is going to give it more strength. And also the PVC is going to be more heat resistance rather than the 3D printed material. I did that from my own experience. I 3D printed some parts and I left it in the car. It wasn't a hot day. And when I came back, I found that the parts had been bended due to the heat. So you cannot demand on that if you're going to send that to a real work in the farm under the direct sun. It will get damaged in less than 1 hour, not even days. The PVC pipe, the length, cut to length by using the circle. So this component will be used to connect the equal T junction to the adapter and so on. 3D printer also can be used. Well, they just put it as an alternative process, but in all the cases, if you would like to have alternative process for all the manufacturing process we just done, The whole pump, except the rod, can be done by the die casting, by injection molding, sorry. We can have the mold and just inject mold all the parts, and then you can use it directly. But of course, you know that the main pump has made by which operation? What do you think? How we made the PVC pipe? Sorry? Do what, the first one? I know how we cut it down. I mean, how we made the shape of this. How does these pipes has been made? Another suggestion? Actually, what we have is very simple process. We call it the extrusion. So what we are going to have is a die. The die is going to have the circular shape, and we have mandrel in the middle. So we just squeeze the material from the other side, which is coming from the screw conveyor. We put the pellet or the PVC on one side, we heat it, we melt it, then we start to inject it. The outlet is going to have a cylindrical shape of the pipe. To cool it down, usually this will run directly in the water path to be cooled down, and then we're going to have the pipes. We just cut it to the, for example, this one's 6 meter length. We're going to cut it to 6 meter length or 3 meter length according to the application. We usually try to avoid having too long because it's tend to bend. PVC pipe, 80 millimeter length, cut with the circles. So yeah, we just don't mention how to make the PVC pipe, or it's only how to prepare the part itself. The steel rod, 6 millimeter with the thread, cut to the length of 325 for his case, threading 25 to 30 millimeter at both ends, and steel rod was used to provide the prototype. PVC rod could be also have been used. No, it's not going to be used. Maybe we can have another alternative, but it's going to be quite expensive, like the carbon fiber one, doing the. Yeah, I know we can do it, but anyway, it's going to be more flexible. Actually, it's not going to break. That will be the advantage of it. The piston components. This component was 3D printed. For your case, it's going to be machined, and 3D printing can be the alternative method. The other alternative method we said is going to be the casting of the plastic, and the third method can be the injection molding. Okay, so the rubber seal to be attached to the piston, and that's actually was he did with laser cutting. We cut it by hand. The other method to cut it is simply we can have the custom cutter, which is going to have a single circular shapes, like the one we use the punching. Have the circular diameter, but it wasn't enough to have the same diameter. Actually, we can have the exact diameter, and we just keep on the rubber sheet and get the circle shape. The valve components, 3D print for his case. The rubber sheet to be attached to the piston, once again, was laser cutted. You can say manual cut for your case. The PVC pipe, the one at the top, I think, that's the main body. Okay, the component was cut to the length using the circles. So, what else? I think that's it. Okay, so the detailed description of the process and the operation. He said that the process mind the final valve. Oh, that's the description on how they did the design and how they did any proposed modification for it. So majority of the process operation of the construction pump was remained at the same as those proposed in the section 3.1. So he didn't change the first idea he has. I think that's one of the group we had. They 3D printed the parts, and later the parts has been taken off. They couldn't find it. So we have to make a new pump. We machine the part for them, so they can mention that in their report. So process of determining the valve design, how they did that. Okay, so I will show that. I saw actually some students who made multiple valves. I made the test for one of the groups who made actually 2 valves. We tested 2 valves for them. The second valve gave more flow rate than the first one. They just changed the pattern and it's worked. I can write down a comparison between the two different designs. Okay, now the joining process, which is the assembly process. The connection of the smaller units name 1, 2, and 3, as mentioned here, is going to be by the tight fitting. Units 7, 8, and 9, we have the threaded rod, and we use the, of course, the nuts to do that. 4 and 5, units 6, 10, and 11. Okay, so again, they had another flow chart for how the parts were simply connected together to have the final assembly. Okay, so I will leave that for a while so you can read as well. Assembly of the final parts, you can simply write down how much time was required to assemble the pump here. And the testing of the completed pump using the test rig, we can simply just write down the same information we had on our sheet to be added here, or you can simply just refer to the figure, whatever the thing is, and put the scanned document of your test. So instead of writing down your own table. That's strange. How they got 4? Yeah, how they got that? 4.1, then 9.75. Anyway, the second one meant to be more reasonable, but for 80 millimeter diameter body, usually we get the range of 20 liters. Performing to the required standard for the two tests, it was believed that the efficiency of the pump could be improved. Yes. So hot glue was used to increase the efficiency of the units 6, 10, and 11. The hot glue was placed on the connection. Well, the hot glue, by using the hot gun, is actually a temporary solution. It's not going to be the perfect solution. So usually if you would like to have the things to be solidified, we're using the thermoset material, which is the epoxy, for example, because it's going to have chemical reaction, solidify, be a part of the main body. So they just did that and run another two tests, and they increased the flow to 11 and 11.25 liters, which is good. They went to test number 6. I don't know what they changed there, but the test number 6 was run in the way that tracked the time taken from 1 liter to flow out of the pump. Each stroke, oh, that's too much. And they actually didn't improve a lot, in my opinion. Summary of manufacturing and the testing of the pump, and then the quality assurance and the inspection, the estimation of manufacturing cost. First, for the quality assurance, you can say that you were doing the testing as you making the part. All the parts we machined, all the pistons we machined. Actually, we assembled the piston without the holes in the main body, and we tried to push it by hand using the rod, and we tested the pressure generated on the other side. This will tell you how good the tolerance we have around the valve itself, or if we're going to add the lip seal around it. So we usually found that the pressure is going to be quite good before we start to do the drilling of the inlet holes, and this to prove that the part's working. When we put the washer, we tested the thing on the water directly by trying to pull out the water. If it's worked fine, that means that the whole design is good. So estimation for the manufacturing cost is actually going to be good if you are going to add the assembly and the assembly cost. For the labor, it said that the number of the hours is 8 hours. I think this will include 3D printing, because I can tell that we made pump, workable pump, in less than 1 hour. I did myself. Okay, so I cut the part, I machined the piston, and assembled the thing and make it work in 1 hour. Carlo, who was working here, he did the whole thing, he said, in 25 minutes, because he designed the whole project, so he knows what he's doing. But anyway, for me, I wasn't in a rush. The people were around, and I was working and helping, and I did the whole thing in 1 hour. So 1 hour, this will make it more economical if you're going to do the work. Just remember that in the real life, that we're going to make the part individually. So we may have 3 workers, each one is going to do a single job. One of them is going to go to the machine, cut the valve and the piston valve, the piston and the valve, the bottom valve together. Okay. Another person is cutting the PVC pipe. The third person is preparing the rod. Done. We have all the components ready. So we can assemble the part. If they're going to work 3 in parallel, we can finish that very soon. Well, even cutting the rod, he can cut the washer at the same time. So we're only going to assemble the parts. Because $356, that's too much. I don't know if he added the material. Yeah, he added the material here. So once again, I think this will be too much. Yep, PVC pipe, $6. Electrical tape, rubber for the seal, the hot glue, super glue, the equal T connector, the steel rod. Or maybe they bought a steel rod. I said maybe they didn't use ours. 3D printing material costs them $154. Wow. Okay, nuts and bolts, and the total was $189 for the material, and I don't know how much it costs for the labor, $356. So the pump costs them $550. This is not cost efficient. We can have a DC pump. Sorry. Yep. Actually, with this cost, we can buy a DC pump and small solar panel, and it's going to work for $150, right? Even less. I don't know that. Okay, final assessment of the pump. I have this sheet here. Okay, and I think that's done. Oh. I didn't fill this side anyway. Okay, the preferences. Okay, and the reflection. Now the reflection is going to be individually. So every member of the team need to write down his own paragraph about your reflection about the work. So you can see here that the first person, Mark, said that working with the team has been pleasure given our relationship. Yes, that's the most important thing. The combination of everyone, dedication to, and the efforts point early on has led to the environment where everyone does their assigned task. Okay, what else? The most important thing that the student learned how to build something. This is your first subject, you build something, right? Have you did the MD1 yet?
I did intro to making it.
Oh yeah, and
that was code, so we didn't get to build it, so we did
they used to build the wind.
Yeah, the wind.
Yeah. Yep. Anyway, so that's what we have here. Later, if you're going to do the advanced manufacturing, we will teach you not simply the working with the hand, but for example, we'll try to show you how to use the more advanced technology like using the CNC machine. Typically, we're going to teach you how to use the CAD/CAM software, how to, for example, sketch this pump and how to cut it to the size. So we get the block and we're going to put it on the milling machine and how to do the cut to design shape. What other thing we can teach you? How to use the robotic arm to assemble the parts in a very simple manner. We will teach you how to do the measurement by using more advanced technology. Now, what I'm suggesting for next semester is, because actually what we're doing right now was similar to what we did in the lab, but we take an actual measurement, up to 30 measurements, and then we start to do the analysis for this measurement. That's something you hadn't do in this subject. Because we have something called the uncertainty analysis. Next semester, you're going to use the image processing to do the measurements. Okay, so these are some example of the individual reflection, and I think this will be the last part. Uh, it's meant to assign you against this part in addition. So that's why you can find that some of the students going to get 98, other going to get 100 for the same report. It's going to depend about the quality of the reflection section you are going to write down. And that's it. Okay, so I think I'm going to start recording now. 35 minutes is quite long discussion.